In this video, let's learn how to write APIs that conform to REST style or constraints. API stands for Application Programming Interface. You all know that. You have seen and used a lot of APIs. They're everywhere, really. For example, in your CS1 and CS2 courses, you have used different kinds of Java APIs. There's also an awesome Java API documentation. I hope you guys enjoy that. When you learn operating systems, you may also have used some OS APIs. Well, in this context, we're talking about web APIs. That is, API based on HTTP. So think of API as a contract between client and server. So server is providing API, and client is consuming or using this API. You have actually already defined several APIs and written them down in an API documentation in this course. For example, /find by page, /find all, find one, delete by ID, and so forth. Then what is REST API? How does a REST API differ from the APIs that you guys have written before, like find by page, delete by ID, find all, and find one? Well, REST stands for Representational State Transfer. It is a software architectural style for designing web APIs. Well, you don't have to use REST API, but it's highly recommended to design an API that conforms to REST style or constraints. The core concept in REST style is resource. This means that in REST, we treat objects on the web as resources that can be created, read, updated, and deleted. So when you design a REST API, we're talking about resources or things, not verbs, not operations. In other words, you should only input nouns in your API URL. So things like find by page, delete by ID, that all the API URLs you have written, they are not REST API or they are not RESTful. So let me show you some REST API and non-REST API examples in one table. So take a look at this table. Let's assume the base URL is www.hogwartsartifacts.com. In this example, I defined 5 API endpoints in both REST and non-REST style. By the way, an endpoint is the URL where an API can be accessed by a client application. The second column describes REST API endpoints, and the last column is non-REST or action-based endpoints examples. In this example, the resource our server is managing is called artifacts, the magical artifacts from Hogwarts. It can be one artifact or multiple artifacts. In REST, if you want to get all resources, the endpoint looks like this. Now, of course, the complete path is this one and this one together. So column 3 explains the meaning of this endpoint. If you want to get only one resource, in this case, I want to get an artifact with ID 101, then this is the syntax for the endpoint. Artifacts / artifact ID. In this example, 101, this artifact ID, is something called path variable. Since it is a part of the path, please do not confuse this with request parameter in a query string. There's no question mark, there's no ampersand. They are different. So one is path variable, the other one is request parameter. They're different. Then what if I want to create a new resource? In this case, I want to add a new artifact into the collection of Hogwarts. The endpoint looks like this. It is exactly the same with the first one. Get all artifacts. Then you're like, wow, they have two same URLs. Then how does the server differentiate the two APIs? So the server knows whether I'm going to return a list of artifacts or I create a new artifact. The answer is, even though they have the same endpoints, but they have different HTTP methods. That's the first column. We also call HTTP methods HTTP verbs. So the endpoints in REST API tells the server which resources that we're interested in. We means the client. And HTTP methods tell the server what operation I want to do with the resources that I'm interested in. So really the meaning of a REST API based on two things: HTTP methods and endpoints. In this case, column 1 and column 2. As you can see, this is very different from column 4, that is action-based endpoints, because here in action-based, the meaning is in this endpoint. Well, in fact, you can do all of them in just a GET and a POST request, because in action-based, the server does not rely on the HTTP methods to understand the meaning. But in REST, you have to have two things in it. Here, I want to talk more about POST and PUT REST APIs. Unlike GET REST APIs, where you can put the parameters as path variable, in POST and PUT, the client needs to send data along with the request in request body. That's why you didn't see the new artifact and modified artifact in these two rows. You only see the HTTP method and REST endpoints. But the data, in this case, a new artifact and a modified artifact, they are actually stored in the request body, and they are sent along with the request. So in summary, if you are a client application and you want to use a REST API provided by a server, then using this API depends on two things: an identifier for the resource you're interested in, that is column 2, which is endpoints. The operation you want the server to perform on the resource you're interested in the form of an HTTP method or HTTP verb. Once you have implemented all your REST APIs on the server side, you want to expose them to the public so your clients can use them. But you don't want some random customer or user or client to use your API to get resources and modify them, right? So how do we make our REST API secure? Here I list the 3 popular approaches: HTTP authentication, API keys, which is very popular, and even more popular, OAuth 2.0. Okay, besides the APIs that are written by yourself, in the world, there are actually a lot of public APIs provided by other organizations or companies that you can use. Some of them are free, and some of them are paid. On GitHub, there is an awesome repository that has a collective list of APIs. If your server needs some data from a different API, so your server can also request API. Okay, so the client here doesn't really have to be a front end like a browser, right? Your server can also be in the role of a client when you request some service from a different server. So server requests service from a different server. So let's go there and take a look at some popular APIs. As you can see, this is a very popular repo because it has already received almost 80K stars. Okay? It has a collective list of free APIs for use in software and web development. So in your project, you may want to consider this list in case you need some services. For example, let's say you're interested in retrieving some data from books, right? So let's go to books. And here are some free APIs that offers books data. For example, let's go to Open Library, okay? Just random one. As you can see here, so here it says no need authentication, it's public, and it needs HTTPS, okay? So let's click Open Library. And that one leads to the website of this API, okay? And this is not part of GitHub. So for example, let's go to books. And it describes the request format. So when you make a request, you can attach those as query parameters, like beep keys, ISBN, and so forth. And here, that's a promise. If you follow my request format, then this API will return you those response in this format. So for example, this is the endpoint. As you can see, this is a REST API because this is a resource-based. Here's books. So if I copy it and paste in my address bar and click return, and here is the response I get from this API. Okay, so let's go back to our lecture notes. In order for an API to be truly or strictly RESTful, well, many companies or many servers, they claim they are RESTful, but in fact they're not. So what defines RESTful? Okay, in order for an API to be truly RESTful, it has to conform to 6 constraints. Well, the last one is optional. So they are client-server separation, stateless, cacheable, uniform interface, layered system, and optional code on demand. The last one is not required. So that means it has to conform to 5 constraints. So let me very briefly talk about each. If you're interested, here I include a link. First, REST is used in a CS architecture, that is client and server, no surprise. Second, stateless. That means the server side contains no client status or state. Each HTTP request from the client side should contain enough information or context for the server to process the request. The session state is held on the client side. Now this implies that any server applications that uses sessions to store the information of a client is not REST. That means everything we have done so far are not REST. And remember, in servlet, we have something called JSessionID. We're using JSessionID to find a session for a client, and we can save something in the session and retrieve it. That's not REST. In REST, all the information about the client has to be on the client side, not the server side. Third one is cacheable. That means the result from the server can be cached on the client side or anything in between client and server. For example, a gateway in between the client and server. The fourth one is uniform interface. Now, for us developers, if you're a developer of this REST API, that means you need to use proper HTTP methods or verbs for each request. You have seen that. Remember the column 1 in the table. And also the endpoints only contain nouns or noun phrases or the resource name. Don't use any verb in it. So it's really a convention for naming your endpoints. Also, you need a uniform HTTP response code. The fifth one is layered system. That is, the client cannot assume a direct connection to the server. As I said, in between a client and a server, there may be multiple layers. For example, gateway, routers, load balancer, firewall, and so on and so forth. The last one, code on demand, is optional. It means that the client is allowed to request not only resources, but code from the server side and execute it on the client side. This will greatly help reduce the load, the computing load of the server, because the server says, hey, I'm just so lazy. Here is the code, and I send it to the client. You can execute it on your machine. That's called code on demand. But this is optional. You don't have to use this to be truly RESTful. And violating any constraints other than the last one, code on demand, means that your API is not truly or strictly REST or RESTful. Then you will ask, why REST? Okay, we talk a lot of things about REST, okay, about this and that, a lot of constraints. You're gonna ask, why bother? A benefit is that using REST API will further or will completely decouple your server side and client side. I'm sure many students already realize the importance of decoupling, right? If you have two things that couple together, then changing one thing will also affect other things, okay? So what is the benefit of a decoupled server and client? That will make it easy to scale up the server side without affecting the client side. For example, if we make your application stateless, that is, the server no longer keeps track of the state of the client, then the server can feel free to scale up because it knows that even if I scale up, I will not have to replicate all the sessions that I have already remembered. Other than that, REST APIs provide simplicity, modifiability, and portability. More of the non-functional requirements benefit if you remember the topic in software engineering. That is, using REST API can improve a lot of utilities like simplicity, modifiability, portability, scalability. That is why REST or RESTful APIs are becoming more and more popular in large companies. If you're building a small application that only have 100 and 200 users, you probably don't need REST. Okay? And this is very useful for large applications. Well, in summary, when you write a REST API, you write endpoint in terms of resources, nouns, not actions. Use HTTP methods or verbs to indicate what to do with the resource. And use HTTP response code to indicate status, either success or failure. And use JSON format to exchange data between client and server. All those are considered as good practice.